Hi friends, hope you are all fine. Today's video is about basic medical statistics. Community medicine stands on two pillars, epidemiology, another one is statistics. Today we are going to see statistics, quick revision. I have divided this chapter on statistics into three main parts. Part A has the health informatics, that is about data. Part B has details about the presentation of that collected data, how to do that. Part C is about how to analyze the collected data, some basics in statistics. So these are the three major subheadings under which I am going to cover statistics today. Coming to part A, health informatics. So we can see here data, information and intelligence. What is the difference between these three? Data, something like suppose we have a collection of details regarding 10,000 people's height in a particular area, say in Tamil Nadu. So this is just a discrete observation. It is not going to give any meaning. So data is discrete observation of attributes or events. It has no meaning. Second thing is information. Suppose you summarize and you derive meaningful information out of the data. For example, with that same 10,000 people whose height is with you, just you classify them into those who are tall above 180 centimeter, those who are medium height between 150 to 180 centimeter, those who are short below 150 centimeter. Then it becomes information. Information is reducing, summarizing, adjusting for age and sex so that comparison becomes possible. Still you will not get meaningful information out of it. So what is the next thing? Intelligence. Suppose this same 10,000 data which you have summarized into a proper information, you compare this Tamil Nadu data, that is the tall people, medium people and short people, with Andhra Pradesh. There are about 10,000 people in Andhra Pradesh and you are also classifying them into tall, medium and short. And then you compare between Tamil Nadu and Andhra Pradesh, it becomes intelligence. Intelligence is integration and processing based on the social and political values. What are the components of health information system? There are various data with respect to health which is very important for us, like demography, the details regarding the population size, the vital events, the birth rate, death rate, marriages, divorce, mortality rates, morbidity rates, disability rates, health resources. So why do we want to collect this data regarding all these things? This is the thing, this is the uses of health information system. First thing is to measure and quantify the information. First of all, only if you know how much is the health problem regarding in a particular area, in a particular place, then only it is possible for us to take the next step. Next step is local, national and international level comparison. The data which you have collected, which you have summarized into information, which then we can compare it with at local level. At national level, what is the problem of tuberculosis? At local level, what is the problem of tuberculosis? International level, what is the problem of tuberculosis? Then we will know, okay, our country has more number of tuberculosis patients, so we have the most problem in the whole world. So third thing is for planning, administering and management of health programs. So once we know that this is the quantity of problem, then we can direct the resources for that particular program. Like so many number of people are there, so in so many districts they are affected. So we can allocate the resources in those particular areas and we can implement the national program. Fourth is assessment of performance of the program. Suppose for a program we are implementing, the dots is being given, whether it is being properly implemented, whether the patients are getting benefited. Fifth thing, degree of satisfaction of the beneficiaries, and also for research purposes. The most important thing for data is for research, for further exploration of new knowledge. Definitely data is needed. What are the sources of information system? There are various sources. It could be a 10-mark question also for you. That's why I have put in a separate 2 slides for you. Sources of health information in India, it is most important is census. This is collected every 10 years. It is a total process of collecting, compiling and publishing the data. So it covers the whole of India. Census Commissioner of India is the person responsible for collection of the data. The most important drawback is it's a lengthy process. It is going to be done house to house. Next is the registration of vital events. It's a very good source of data. We all know that the birth and deaths should be registered. Similarly, there are other events like fetal death, marriage, divorce, adoptions, everything should be actually registered in the Registry of Vital Events. According to Central Birth and Death Registration Act, recent amendment, both birth and death should be registered within a period of 21 days. And because it is a very difficult and field process, the use of non-medical person in collection of vital statistics is called as lay reporting. Then sample registration system, SRS, it's a very good source of health information. Why? Because census is taking lot of time, 10 years, but sample registration system, so every year it is systematically being collected. Also, it is a very good reliable estimate of birth and death. It is a double recording system. One side there will be a continuous enumeration of birth and death by an enumerator, and on another side there will be an independent survey every 6 months by an investigator and supervisor. There are 3 diseases which are internationally coming under international health regulations that they should be immediately notified. What are these 3 deadly diseases? Cholera, plague and yellow fever. And there are some other diseases which are notified by WHO as diseases under international surveillance. What are they? Louse-borne typhus, relapsing fever, polio, influenza, malaria, rabies, salmonellosis. And what is the problem with notification system? There is a huge problem of under-reporting because the private practitioners, if the patients go, they don't take much interest in reporting these cases. Then it becomes a problem. Then clinical and subclinical cases can be there, which can be missed by a clinician, so it will not be notified. And what are the other sources? There could be record linkage and medical record linkage. That is bringing together records relating to one individual originating at different time and different place. Like he could have gone for some problem for surgery some time before, he could have gone for vaccination during his childhood. So you are linking his vaccination status and surgery status at a time. That is a so it is as you think, it is very difficult because a country which has a very good record keeping system can do this, but it's not possible in all developing countries. Medical record linkage is actually the health data compilation of an individual. And epidemiological surveillance. There are national programs for some diseases. Under these programs, there will be routine surveillance that will be undertaken. So, this epidemiological surveillance will give us a good source of information regarding these health problems. And then other health service records, polyclinics, private practitioners, MCS centers, immunization, diabetes, hypertension clinics, those which are missed by the public health system, government machinery, they all go to private machinery. So, if you collect data from the private practitioners, it's going to be a complete record for us. Environmental health data is very important. As we all know, food additives, industrial toxicants, the waste disposal system, solid waste, liquid waste management, so many things are there in environmental health, and this is being separately collected under the Industries Act. Health manpower data, it gives us details regarding the resources that is available to us, the doctor population, the nurse population, the name and details, everything is published by Directorate of Medical Education. Population surveys are increasingly becoming a very important source of information. That could be health interview survey like National Sample Survey, the National Family Health Survey, District Level Health Survey. These are conducted every year. Okay, we have completed part A. Now coming to part B. This is data. Okay, now we have the data and what to do with that data, how to show that data. Now we have two types of data, primary data, secondary data. Primary data, which is that data that is directly obtained from the individual. Secondary data is data that is obtained from the primary data. So which is a very good source of data? It is actually the primary data because it's directly from the source. Now, how to present the data? There are different methods I have put up here in the left side. Tables, charts, diagrams, pictures, special curves. You take tables, it should be properly labeled. What is the title? What is the number? What is the table number? What are the headings of the columns and rows? Whether the data is arranged in order. It could be in any order, but there should be order, chronology, time or geography, place. And percentage wise it should be there, and vertical arrangement is always better because the human eye is trained to read it easily and interpret easily, the vertical arrangement rather than a horizontal arrangement. And there are two types of tables, simple table, frequency distribution tables. All these things are given in part. Nice diagrams are there. Please look into the diagrams. Class interval, like we can have 5 to 10, 10 to 15. So if you represent those individuals, then your class interval becomes 5 because the interval between the groups is 5. Coming to the charts, we have different types of charts. Simple bar chart, multiple bar chart and component bar chart. And then histograms are pictorial representation of the frequency distribution. And the frequency polygon is obtained by the joining the midpoints of that histogram bar, you will get the frequency polygon. Line diagrams usually are very helpful in showing the trend of events with passage of time. With passage of time, whether disease is increasing or decreasing or same, we can identify with the line diagram. Pie chart is usually useful for less number of data. For example, male and female we have to show. We can show in a pie chart where male is this much, female is this much. But it is not advisable to use pie chart when the data is more. Coming to pictures, pictogram is a very good representation of data for a layman. Relationship between two variables we can see with the help of scatter diagram. So all these things, diagrams are there in Park. Please practice these diagrams. It is also a very important essay question for you. And the last part and the most important part, and which is not understood by many students, not only medical students, even by postgraduates or by clinicians, is this statistics. Let me make this statistics basics very simple for you. Basically, first of all, in any statistical studies or anything, we have to first of all understand this basic concept, normal distribution curve. And actually what this curve represents, I will show you a simple example here. Just see on the left side. Okay, we have a group of people, say in a class there are 100 students are there. And again I am going to take the same example, height measurement. We are going to measure the height of the 100 students. And I will ask you one simple question. How many students you expect that their height will be above 180 centimeter? Maybe like 4 or 5. Those are so tall. And how many students you are expecting that their height will be below 120 centimeter? Again, it's going to be very low, 4 or 5. But how many are in the medium category? Between 120 to 180 centimeter, you can see so many people are there in the center part. So what I am coming to say is that is what is that normal distribution curve. All the biological variables follow normal distribution. Center portion of the figure represents the average height people on both sides, like the above 150 centimeter to 180 will be in this side, 120 to 150 may be in the left side, but beyond this it will be less. Left side represents the shorter individuals, and we expect lesser and lesser individuals as we go. Like for example, the cutoff we have kept here is 120. Here is 150. Okay, below 120 if you go, it is very less number of people. Probably here we can put the cutoff 90. Below 90 if you go, and we can put another cutoff 80. Below 80 there could be nobody or there could be one. Similarly, coming to the right side, the cutoff is here 150 to 180, there will be most number of people's height. 180 to 200, maybe these many people are there. But above 200 is extremely rare and very rare, above 200 centimeters in height. So this is what the right side and left side represents. And this is the normal distribution, a bell-shaped curve or Gaussian curve. And this is the property of not only height, weight follows normal distribution, blood pressure follows normal distribution, diabetics, hypertensive. You take any biological variable, everything and anything in our body follows normal distribution. So what the statisticians did is, they took this curve and they took this curve as the golden standard normal thing for calculation of all statistics in the future. We have to have an area under the curve. And so what they did is, they calculated the area under this normal curve. And please understand, this is a statistical calculation. Don't worry about the values. But this is being done, this was done by a team of statisticians and mathematicians. And how these values come is beyond our scope. But we have to know this one thing, the data regarding this is 0, the center point. We all know this is the mean of this distribution. The mean, median and mode, which we will see later, everything should coincide in the center. And then this side is -1 standard deviation, on the other side is +1 standard deviation. I already told you between these two areas there will be maximum number of values. So what we are seeing here is the dispersion between -1 standard deviation and +1 standard deviation. We can see 68% of the values, that is 34 plus 34, approximately 68% values. Suppose if you take this end and this end, -2 standard deviation from this side and standard deviation from the right side and left side, if you take, we can get 95% of the values. For example, 95% of the height of the individuals will fall between this -2 and +2 standard deviation. Right? Do you understand? So -2 to +2. And beyond this +2, we have, like imagine this above 180 centimeter individuals we are going to see. It's going to be, they are going to be here. Below 110 or something, they are going to be here. So that is beyond this 3 standard deviation. We can actually, what is missing here is the area under minus 3 standard deviation and plus 3 standard deviation. If you take, it is 99%. But the standard deviation curve doesn't end somewhere, but it is infinity. This side and this side, right side and left side, the curve is going to infinity. So between minus 2 and plus 2 standard deviation, I said 95% of the values are here. 95%. So 100 minus 95, 5%. In that 5%, 2.5% will be on the left side and 2.5% will be on the right side. Do you understand this? So this is the 2.5 plus 2.5, that is 5% of the values will be beyond this. That 5% is otherwise called 5 by 100, and that 5 by 100 we can put as 0.05. Now something should strike in your mind that I have seen this somewhere. Yes, you are absolutely right, and this is the probability value, that is probability of a person of any event or any biological variable falling beyond this 5% range, beyond this side or this side, then that is significant. So this is the basis of statistics. Why we say something is significant? Why? Because that is not for inside this normal area. This is beyond this normal area. When something goes beyond this normal area, we take that as a significant thing. Either it can be a mean or it can be a proportion. We are testing drug A and drug B, and if the effect is same, then it will fall in between this 90 minus 2 and plus 2, 95% range. Suppose the drug A is better than drug B, maybe it goes beyond. You understand? So this is the basic of normal distribution and probability value. Based on this only, the entire statistics is based upon, and the area under the curve is calculated by the statisticians. Now here is the table showing the area of the standard normal curve with mean 0 and standard deviation 1. Measures of central tendency. So we have 3 measures of central tendency: mean, median and mode. Mean is easily influenced by abnormal values. We all know mean is the average of the variables, and it is easily influenced by abnormal values. Why? Because if you have between 100 to 200 the 100 variables, and we have one variable that is 10,000, then what will be the mean? Suppose between 100 to 200 means the mean may be something around 150, but only because of one data, that is 10,000, the mean will go up to sometimes even 2,000, 3,000 like that. Median is more near to the truth. Why? Because it is not influenced by the abnormal values, because median is the midpoint of the values. You arrange either in ascending or descending order and you take the midpoint. That's why it's more near to the truth. And mode is easier to understand, but the location of the mode will be uncertain. Why? Mode is the most commonly occurring variable, most often repeated variable in a data set. So it will be somewhere, maybe the lower values will be represented mode or higher values may be represented mode. So mode can go this side or mode can come this side. Coming to measures of dispersion. We saw the measure of central tendency, that is this area, and now we are going to see the measure of dispersion. How far this side, left side, right side, the data is going to be dispersed. Range is the highest value minus the lowest value, and so it is not a very good measure of dispersion. Coming to mean deviation or average deviation, how far the data is deviating from the mean, that is average amount the value in the data set differs from the mean. From here, how far the data is, and that is mean deviation given by the formula sigma x minus x bar by n. And variance is the deviation of all values from the mean. From the mean, how much is the variance? That is denoted by formula sigma x minus x bar whole square by n. And what is standard deviation? It is the square root of variance is standard deviation denoted by this formula, square root of sigma x minus x bar whole square by n, that is called root mean square deviation. And suppose the sample size is more than 30, it is okay. Suppose the sample size is less than 30, we take the correction factor n minus 1 here. And what is the standard normal deviate or variate? It is the deviation from the mean in a normal distribution curve. It is given by the symbol z. Okay, it is very important to calculate this standard normal deviate. It is given by the formula observation minus mean by standard deviation. That is, it indicates how much an observation is bigger or smaller than mean in units of standard deviation. Z gives a value that is corresponding to that value. We can find the area under the curve, then we can calculate the probability value. Suppose the relative deviate is 0.0, it is 0.0, and likewise the area under the curve is given. I already told you at the beginning of this statistics that area under the curve is calculated by the statisticians. This is what I am showing you here. The area under the curve is this. For corresponding to the deviate, relative deviate value, the area under the curve is denoted by this. This is the cutoff here 2. The 2 represents the 95% confidence interval. So beyond the 2, if the value of relative deviate is 3, 4 or 5 or anything like that, it will be significant. Why? Because the area under the curve is more than 0.4772. So if you minus 0.05 by this value, it will be less than 0.05. That's why I am saying beyond 2 it's going to be significant. Below 2 is going to be not significant. So this is a basic framework of any statistical analysis which you must remember. Step 1, choose the appropriate sample. Step 2, find out the standard deviation and mean of the sample. Step 3, fit your sample inside the normal distribution curve by finding out the standard error. Step 4, set up 95% confidence limit. Step 5, find out whether the standard error or relative deviate is within the confidence limits, and then it becomes not significant, or the standard error or relative deviates it's outside the confidence limits, then it becomes significant. Okay, so coming to the sampling methods for any statistical test, first of all we have to take a sample, because we cannot do a test in a whole population. That's why if you take Tamil Nadu, it has a population of 7 crores. So you cannot do a study of prevalence of hypertension in Tamil Nadu by taking 7 crore population. It is impossible for us to do. And that's why we select a sample. And this sample is taken in various methods. And we are going to see that how to select the sample from this universe. We can select either by simple random sampling, or systematic random sampling, or stratified random sampling. When we use table of random numbers or flipping the coin method, then it is simple random sampling, where each and every individual in the universe has the equal chance of getting represented in the or getting selected in the sample. Systematic random sampling, here if you have 1000 houses, the 1000 houses are numbered, and every fifth house if you are choosing to select as a sample, then you go as the first number is selected by table of random number. If it comes 6, from there you go to 6 plus 5 11, 11 plus 5 16, 16 plus 5 21, like that we have to go every fifth, and that is systematic random sampling. Stratified random sampling, suppose we are having two different types of population, then we have to first divide them into 2, and in that stratified group we are going to collect the sample. When we take repeated samples from the same universe, there will be different means and different standard deviation. So it is represented by a formula, that is standard deviation by root of n. So as we see from this equation, the standard error depends upon the sample size. If you increase the sample size, the standard error will decrease. So that is the same thing here in sampling error, where we take a maximum possible sample size which should be bigger, and at the same time, because of individual variability, you will not get the same results because they are all biological samples. Coming to non-sampling error, again it can occur because of instruments and various other factors. Again it is a biological sample, there could be possibility of lot of non-sampling errors. So this we discussed standard error of the mean. So this is what we are going to calculate in all the statistical tests. So what we calculate in test of significance is that either it is the standard error of the mean, that is how reliable is the mean is going to be, that is the sample from which you have, this is a sample from which you have calculated the mean, and what is the relationship between this sample mean and population mean, that is a universe real mean which we don't know. So that is what is statistical test is all about. So to find out that, we keep a 95% confidence limit, and we all studied about this standard normal curve. So we keep 95% confidence limit between -2 and +2 standard deviation, whether our sample mean lies within the same as the population mean. That is what we are going to see. So population mean we cannot directly calculate, but population mean we can estimate with the help of the confidence limits, that is mean plus or minus the standard deviation. So based on this, we can calculate the 95% confidence limits, and we can estimate whether our sample mean is the same as the population mean. So this is what we are doing in all the test of significance: the standard error of mean, standard error of proportion, standard error of difference between two means, standard error of difference between two proportions, or chi-square test. We are finding this standard error. So I have compiled everything in a single slide. The standard error of mean is given by the formula standard deviation by root of n, and this is a simple example of the sample size 5, standard deviation 17. We get standard error of 7.6. So what is the area under the curve? Similarly, in a standard error of proportion, we have the formula root of pq by n. That is, p is the probability of a chance occurring, and q is 1 minus p divided by the sample size, and we get a sample error. So we can estimate the standard error of proportion by this formula. Similarly, if there are more than two groups and we are going to compare the means, we use the formula for standard error of difference between two means, which is the standard deviation of first sample by sample size plus standard deviation square of second sample by sample size of second population, and square rooting it. We get standard error of difference between two mean. Similarly, the standard error of difference between two proportions, I am sorry, I have typed it wrongly here, root of p1 q1. The same formula here, but we are applying the square root and adding the 2. We get the standard error of difference between two proportions. And in all these tests, what we are actually studying is, we are getting either the standard error or the relative deviator. That is, after we find the standard error or normal deviate for two or more groups, we go for setting up the confidence limits, which is generally 95%, and we are going to find out the p-value. And what is the area under the curve? Suppose if it is, I already told you, if it is more than 2, it is going to be significant, and the p-value is going to be less than 0.05. Or if the p-value or if the relative deviate or the standard error is less than 2, what will happen is the p-value will be more than 0.05, and it will become insignificant, not significant. That's all about the test of significance. And for standard error of difference between proportions, we also have chi-square test, which is separately given. It is another method of estimating the standard error, and we use the formula observed minus expected by expected, and expected at row total into column total by grand total, and then we calculate the degree of freedom, row minus 1 into column minus 1. So this is the steps. Step 1, framing the null hypothesis. Step 2, find out the chi-square value. Step 3, find the degree of freedom. Step 4, find the p-value for chi-square value and degree of freedom. And step 5, accepting or rejecting the hypothesis based on whether the p is less than 0.0 or more than 0.05. This is the same 5 steps for anything and everything you do in statistical analysis. And there are other methods of association between two variables. One is correlation, another one is regression. Correlation is given by the symbol R. The value varies from -1 to 0 to +1. Minus means negative association. If one value increases, the other value decreases. One is positive association, that is, if one value increases, the other value will also increase. For example, if the weight increases, the cholesterol value will also increase, means there is positive correlation. Regression is a more stronger analysis of association between two variables. It's given by a simple regression equation, y is equal to a plus bx, which you know is the equation of a straight line. The x is the predictor variable, b is the coefficient estimated by regression, a is the intercept, again estimated by regression techniques in statistics, and y is the predicted value calculated from a, b and x, and we can measure the association. If you like this video, put your likes. If you have anything to suggest, put your comments below the video, and please do not forget to subscribe this channel, Community Medicine Made Easy. Thank you very much. Meet you all in the next video. Until then, goodbye from Dr. Karthikeyan.